Simplifying radicals can be really complicated. So let's try to simplify the simplification. Let's get into it. Hi, I'm Sarah. I've been a STEM science and math teacher for over 20 years, and I'm here to make science and math engaging and fun and not so scary for everyone involved. Are you looking to avoid the summer slump? If you're feeling a little nervous about going into high school Algebra 1, you just need a little refresher. Are you a parent who's looking to be able to help your student with Algebra 1 next year? Come join my summer boot camp. We're going to be reviewing some pre-algebra topics that you're going to see again. We're going to be previewing some Algebra 1 topics that you will definitely be seeing. It's just going to be 1 hour a week, really small class sizes, being able to individualize. Sign up for the boot camp today. What you want to do is when you're simplifying these radicals, you want to look for the perfect squares. So looking for factors of this number that are perfect squares. So 27 is 9 times 3, right? Now 9 is a perfect square. So I can take the square root of 9, but I can't take the square root of 3 without going into decimals, right? But I can look at the square root of 9 is 3. And then the square root of 3 is just the square root of 3. So that's how you would simplify this with that radical symbol and those numbers, right? Those values. So you would be looking for the perfect square, and then that's the way that they can get out from under the radical symbol, is if you can take the square. So something like the square root of 50. So how would you simplify the square root of 50? So you can certainly just estimate, but it depends on what you're doing. If you're simplifying, right? If you're simplifying, then that is something different than finding the decimal, right? Or estimating, right? So looking at this, square root of 27, well, the next highest square root would be 36, and the next lowest square root would be 25. So we would say that this is a little bit over 25, right? Square root of 27 is a little over 5, okay? So square root of 50, if we think about what factors of 50 are perfect squares, well, we've got 25 and 2. So 25 can leave the square root and it becomes 5, right? But 2 can't leave the square root because it's not a perfect square. So this would be 5 root 2. So that's going to be the simplified version of this. Now, when is this useful? It's when you're doing like operations and things with radicals and you're combining them together. And there's a lot that goes into it with some trig functions and things like that. It's easier to work with it in this format than it is to work with it as a decimal, because these decimals are long and ugly and you really don't want to round very frequently, right? I always tell my students, like, rounding is the last thing that you do.